In this video module, we're going to be covering 5.1, the midsegment theorem. So your first task was to complete the investigation at the top of your notes. So hopefully you have made it this far. You may not have answered E yet, but we will do that together in just a second. You are first supposed to draw triangle ABO, which I have in red. Then you are supposed to find the midpoint of OA, which is 0, 4, and OB, which is E at 3, 0. Then you are asked to find the length of the diagonals, AB and DE. Now, there are two ways that I found that AB was 10 and that DE was 5. The first way, you could have used the distance formula. So here's the distance formula. Here are points A and B. I ran them through the distance formula. I got square root 100 for 10. And for D and E, I got 5. Now, you could have also used the Pythagorean theorem, where you count up and over and do a squared plus b squared equals c squared. You still get square root 100, which is 10, and you still get 25, square root of 25, which is 5. So regardless, you will get 10 and 5. Now, the next thing that you were supposed to do is to find the slope of the diagonals, the slope of AB and the slope of DE, and you will notice that they are parallel. So now, using the information that you have already found, it says to make a conjecture, a guess, about the relationship between a midsegment and the side of a triangle. So the first thing we need to say is that this right here is the midsegment. So it's saying them right here to create a midsegment DE. So that is the midsegment. Notice that it's at the midpoints of the triangle. So what's going to happen with this green highlight, the midsegment, and this side of the triangle? So the first thing you will notice is that the sides will be parallel. If you did not make that conjecture, go ahead and write that down. The sides will be parallel. They will always have the same slopes as right here. And 5 and 10, okay? 5 and 10. This was 5, this was 10. Therefore, the conjecture would be that the midsegment is half of that side. So we are going to say DE is equal to 1/2 of AB. Or you could also say that DE, you have to double DE to get up to AB. These are both equivalent expressions. We typically like to use this one. So what you actually just investigated is the midsegment of a triangle, what it is, and we have a midsegment theorem. So moving on to this picture, you will notice something. So this P is the midpoint of this side of the triangle, so midpoint. We have a midpoint here, and we have a midpoint here. So you see all sorts of things being congruent. So what exactly is a midsegment? So this is the official definition of a midsegment. It is a segment connecting the midpoints of two sides of a triangle. So again, it is a segment connecting the midpoints of two sides of a triangle. Now, please take note. This midsegment is parallel here. This midsegment is parallel over here, and this midsegment is parallel here. So, it's important to note that every triangle has 3 midsegments. Every triangle has 3 midsegments. So even though up here in this investigation we did not study it, it actually has 3 midsegments. Now, that's leading us to our first theorem in chapter 5. It is called the midsegment theorem. It says the segment connecting the midpoints of two sides of a triangle is parallel to the third side So when it says third side, it connects here, here. It connects these two sides. Therefore, it's going to be parallel to this side. Now, it is also half as long as that third side. So for example, if this was 4, this would be 8. Now, you also have relationships going on this side, on this side, because the midpoint has happened. So basically, you investigated the midsegment theorem. DE is parallel to the third side, AC, and DE is 1/2 the length of AC. So now you are going to actually see that this is a handy little midsegment, or a really handy theorem to help us solve problems. So this next section states DE is a midsegment of triangle ABC. Find the value of x. So if it is telling me this is a midsegment, then I automatically know I can prove whatever I need to with the midsegment. If this is 7, then x is going to be 14. So it can be as easy as that. Now this one switched from our midsegment, but since it's a midsegment, I know E is a midpoint of that side. So I know AE and EC are congruent. Therefore, x is 8. And then on number 3, we go back to the midsegment. I know that x is 1/2 of 34, so x is simply 17. Now, I would call those super easy problems, just recognizing that the midsegment theorem is at work. Now, question 4 is an algebra problem. You just need to pay attention to what's all going on, and it's actually not that bad. First, you must have a midsegment. Now, you know QR is a midsegment because of these markings. Q is a midpoint, R is a midpoint. Therefore, QR is a midsegment. Now, remember the rule. QR is 1/2 of YW because it is the third side. Now, I showed you in the investigation, sometimes we really do not like to kind of have that half there because we don't like to deal with fractions. So we just make it easy. I'm just going to simply multiply this side by 2, multiply this side by 2, and now I have the relationship that I need 2 of QRs to equal this. So the math is actually a little bit easier. 2 of the QRs, which is 2x minus 3, equals YW, which is x plus 9. So now I have an equation to solve. So I have 4x minus 6 equals x plus 9. Bring the x to the other side. I have 3x minus 9, or minus 6, excuse me, equals 9. Add 6 to the other side. I get 3x equal to 15. Divide by 3. X equals 5. Now again, the only reason that I knew I could do that was that that is a midsegment because of the midpoints. It is parallel to this side, and I need 2 of those to make that. It is 1/2 of that equation. We remove the 1/2 from this side to make our math work easier. Now, flip your paper over, and on the back you are going to find problems. I would like for you to look at those problems. So this is number 5. And this is just me testing your ability of, do you actually know what the midsegment is saying? So it says in triangle JKL, JR is congruent to RK. That tells me R is a midpoint. KS is congruent to SL. That tells me S is a midpoint. Then it tells me JT is congruent to TL. That tells me that is a midpoint. So basically it is telling me all 3 of these lines are in fact mid-segments. So now it's going to ask a lot of questions. Who is RS parallel to? Well, it will be parallel to the third side, so we can call that JL. ST. Who is ST parallel to? Its third side. We can say KJ. KL. Now KL, they went to the side, the third side first, so we move back to the midsegment RT. Now, we are now going to see what SL is congruent to. Now, this is where the math comes in. SL is this one part. So SL, of course, is congruent to KS. It's the midpoint part. So we can say KS. Now, remember that its midsegment is half of the whole thing. Well, half of the whole thing is 2 tick marks. So if this was whole, then this is going to be half. So do you notice how we do the tick marks? So RT is congruent to that side's parts. Now notice this as we continue. JR here is congruent to KR, and you can even say RK. Well, who's its midsegment? TS, it'll get a tick mark, so we can say TS or ST. And now notice how we're marking everything up. JT here is congruent to LT. LT and this would be congruent to RS, which would be here. So basically, because we're dealing with a midsegment, we have relationships everywhere. So now, what I would like for you to do is to pause this video and now follow the slides of the module.